Good morning, class. So what we're going to go over today is subnets and subnet masks. So I'm going to break this down into 2 days. Today is what is a subnet mask, and how to calculate one. And then tomorrow will be what does that mean, and a little bit more in what it means to have 2 network bits and what that means versus 6 host bits. So today, like I said, subnet mask, I'm just going to tell you what it is. A subnet mask is, well, first, a subnet is a subset of a network. Subnet, like a subset, but you're subdividing the network into sections. And what that does is that prevents a lot of broadcast traffic, as well as it increases security, because if you don't have the same subnet mask, or you're not in the same subnet as other computers, you can't talk to them. So I'm here in command prompt and ipconfig. I think that should give me everything I need. Yeah, so here we go, my subnet mask, and this is a very common one, 255.255.255.0. so that means if you don't have the same subnet mask, my computer won't talk to yours. And this is a very common one for a default. And at your home, you probably have this same one. And what that means is on your home network, every IP address is going to start with 192.168.1, because those are the 255.255.255. The IPv4 address and the subnet mask, they're very closely interlinked. So for now, if your subnet mask is a 255, that means your IP address, that number that corresponds, see how they're right above each other, this 255 here, this means that this 192 won't change for anything in that subnet mask, in that subnet. So typically on your home network, everything has a 255.255.255, meaning everything on your home network is going to have 192.168.1. We're going to get more into that tomorrow when we go into what subnet masks means and again, the difference between host bits and network bits. But for now, just know that if it's a 255, the corresponding octet, and an octet is these numbers here, and we're going to get into why it's called an octet very shortly. The corresponding octet, if it's a 255, doesn't change up here in the IP address. So again, this is 1 octet, 2 octets, or the second octet, octet number 3, octet number 4. So again, this is the subnet mask, and everything that on a network that wants to communicate with each other has to have the same has to be in the same subnet, or have the same subnet mask. And we'll get into the difference between having the same subnet mask and being in the same subnet. So I'll get into that tomorrow. And then the default gateway, that's just your router. So default gateway is what is the level above what I'm currently doing. So in order for my computer to talk to anything on the internet, it has to go to a router, which is over there somewhere. And then that router has a default gateway, which is the modem. The modem has a default gateway, which is one of the servers that my ISP owns. And then that keeps going to a default gateway. And then it filters down to the internet, down to the YouTube server, and then it goes back up and back down. But like I said, we're going to get into that later. But this is just at home. This is the IP address of your, if you're only using a router modem combo, or if you are doing like what I have. I have a modem that plugs into a router, and or access point router, and then everything connects to the access point, and then from the access point it goes to the modem router combo. So I'm going to jump over to my subnetting document. So with subnets, you really do need to know the power of 2, because everything's binary, 1, 0. Everything's done in power of 2s. So if you're unfamiliar with them, you do need to memorize them. I've written them out here. And if you don't know what a power is, 1, we need to talk, so send me a message. I'm on campus. And 2, briefly, if I were to multiply 2 by itself 7 times, so 2 times 2 times 2 times 2 times 2 times 2 times 2 would be 128. 2 for 2 to the power of 3 would be 2 times 2 times 2. That's 8. Now, one thing I want you to make sure you guys know that 2 to the power of 0 is always 1. Any number to the 0 power is always 1. And this is really key because notice this is the only odd number. Everything else is an even number. So power of 2s, you do need to memorize those. Notice 1, 2, 3, 4, 5, 6, 7, 8. There's 8 powers of 2. And I said they're octets. That's going to come into play. So let's jump down to 2 extremely different subnet masks. We have 255.255.255.255. Notice that just is 8.1.8.1.8.1.8.1. Again, notice octet means 8, a set of 8. This is a set of 8 ones. And then 0.0.0.0 in binary is all 8 zeros, 8 zeros, 8 zeros, 8 zeros. So again, each one of the section in the above binary number is called an octet. An octet consists of 8 numbers, each a bit. So each one of these is 1 bit. So in computing, you have a bit, and a bit is either a 1 or a 0. And everything in computing comes down to a 1 or 0. The color in your screen that you're watching this on is determined ultimately by a 1 or a 0 somewhere, or a collection of 1s or a collection of 0s. So that is a bit. Now there is a byte, which you're probably, what's the difference between a bit and a byte? A bit is more for transmission speeds and a byte is for storage. So you've heard of a 256 gigabyte hard drive is different than a 256 gigabit hard drive. A gigabit is one gigabit is 1 gigabit. There's 8 bits to 1 byte. So 1 gigabyte, so download speed, a gigabyte, that's a lot. Gigabyte, that only means you're able to download 1,000 megabits, right? Because 1 gigabit is 1,000 megabits. If you have a gig, 1,000 megabit download, that means you can actually, in terms of storage, download at 125 megabytes per second. So if you're downloading a 1 gig movie at a gigabit, 1 gigabyte movie at 1 gigabit speed, it's going to take you 8 seconds. And if you have questions on that, please let me know, because I don't want to spend the entirety of this video going over the difference between gigabit and gigabyte, megabit, or bits and bytes. But please message me on campus if you do have questions. So, yep, I just went over that. So in the subnet mask, each bit represents a power of 2. So let's take a look at 1 octet from above in the 255 subnet mask. So this is it broken down. Notice it's all 8 ones. The power of 2 that corresponds to this first up here, this first bit is representative of the power of 2 to the 7. The second one is 2 to the power of 6. The third one is 2 to the power of 5. The fourth one is 2 to the power of 4. The fifth one is 2 to the power of 3. The fifth one is 2 to the power of 2. The sixth one is 2 to the power of 2. The seventh one is 2 to the power of 1. And the eighth one is 2 to the power of 0. So what we do is you go, okay, if it's a 1, that means yes. If it's a 0, that means no. So if there's a 1 here, then you kind of write down the number 128. Since there's a 1 here, 2 to the power of 6 is 64. So we're going to add all of these powers up together, and they equal 255. That's that number. So now subnetting is very confusing. So if you're not getting this, I understand. Please message me on campus. There's a ton of other videos on YouTube that can help. And there's also a section in your book and section in chapter 6. But the reason I want you guys to take a look at this now is because there's software I would like to get you guys in order to create your own network maps. So, it's really hard to create a network map if you don't understand subnetting, because it's going to ask for you to have a subnet mask. And if you don't have a subnet mask, you can't do the network diagram. So that is the answer to the question that is going to be in the assignment right there. Why do I want you to know this? Because there's software coming down the pipe. So the resulting, so again, if there is a 1 here, that means yes, that is a bit, and that needs to represent 128. If there's a 0, which we'll get to in a sec, that means no, don't add anything. But for this one, because every bit is 1, that means we're going to add the resulting powers of 2 together right here, and we're going to get 255. So what would the following octet equal? Well, again, we have 1, 1, 1, 1, 0, 0, 0, 0. So that would mean we would write here 128. It's going to throw everything off. Whatever. 128. 1 to the power of 6 is 64. 2 to the power of 5 is 32. 2 to the power of 4 is 16. Now we have a little bit of an issue here. Like I said earlier, if it's a 0, we don't actually add these together. So it doesn't matter that this would be 8 because this is a 0 here. This just becomes a 0. This is a 0. This is a 0. This is a 0. So then what is our answer? Well, what we do is we take 128 plus 64 plus 32 plus 16. So, oh gosh, 128 plus 64, that's 192. 224, I think it's 240. Let me double check that. 128 plus 64 plus 32 plus 16 is 240. 240. So this octet would be would equal 240. So the result would look something like this: 255.255.255.240. Okay. So how long has this video been? This has been 13 minutes. So what I'm going to do now is I'm going to post a subnetting question, not a questionnaire, but you guys are going to create subnets from binary and vice versa. You're going to go from binary into decimal and from decimal into binary. And that's going to be your guys' homework for today. So if you guys have any questions, please send me a message on campus. And again, in order to know the answer to the question that the question about this video in the assignment, you have to watch the whole video because I'm not going to tell you where I put it. But anyway, again, I hope you guys are doing okay. I'm going to make this document is going to be available on the Student Resources tab. If you guys have any questions on how to get to that, please let me know and I'll send you a link. Otherwise, hope you guys are doing okay. Stay safe.